Alrighty, kiddos. So today we're going to start a new lesson. It is lesson 17 and 2/10, box plots, or 17.2 on page 491. All right, so the state of Texas expects you all to be able to represent numeric data graphically, including box plots, which is just one of the multiple representations that they expect you all to know. All right, so when using a box plot, ladies and gentlemen, a box plot is a display that shows how the values in a data set are distributed or spread out. To make a box plot, first find 5 values for the data set. The least value, the lower quartile, which is the median of the lower half of the data. The median, the upper quartile, which is the median of the upper half of the data, and the greatest value. A lot of times, ladies and gentlemen, these can also be referred to as this here. The least value will sometimes be referred to as your minimum, and your greatest one can be seen as your maximum, or your lower, I was going to abbreviate it, lower extreme and upper extreme. Alrighty, and then the lower quartile can also be, or will also be referred to as Q1. And the upper quartile will also be referred to as Q3. Okay. But I'll give you guys some more examples right in a bit. Alrighty. So example number 1. The heights of several students are shown. Make a box plot for the data. Alright, so here, ladies and gents, they give us here a bunch of different heights from different students. Alright, so step 1, we need to order the data and find the needed values. All right, so here, ladies and gents, first of all, they put it in order from least to greatest here. All right, so bang. Once they do that, ladies and gentlemen, you need to find the median. To find the median, if y'all recall what we did yesterday, kind of, guys can cross them out like this here. Here we have 2 numbers in the middle. Recall when we have 2 numbers in the middle, ladies and gentlemen, you add both of them and you divide by 2 to find the average, or the mean. I'm going to say it that way. So here, the median is going to be 59.5. Then once we do that, ladies and gentlemen, all right, so what I did here, I just rewrote it on the side to arrange the data to make it a little easier for us to create our box plots. All right, so our median here is 59.5, ladies and gentlemen. Once we did that, we kind of separated the data into 2 sets now, which is right here, okay? So now we need to find the median of the lower set. So let's go and cross it out. I'll color code it this time. Bingo, 1. Once again, we have these 2 numbers here. 56 plus 58, you add both of them and you divide by 2 and you get that the lower quartile is 57. So let me write that over here. It's going to be 57. We know that the median here was 59.5. So now we do the same thing with this side of the data over here as well. So let's go and cross them out. Bang, bang. We have those 2 numbers there, 61 plus 62. Add them, divide by 2. You get 61.5. So that is the upper quartile. And the greatest value here, ladies and gentlemen, that we have here is 65. Well, let me color code it here. That makes it a little easier. 12.5. The greatest one was 65. And the minimum or the least value that we have was 54. So now we have everything that we need. This is also referred to as a box and whisker plot. So you see, here's a minimum value that we had. So we put the 54 right there, that's where we would start off. Then our lower quartile, or Q1, ladies and gentlemen, that is where the box starts. And it extends all the way to quartile 3 or the upper quartile. So you would make it like that. And then the median was 59.5, which is right there. And the greatest value or the maximum was 65. And you would just connect your box and whisker plots like that, okay? Alrighty, so here they're telling us, in the example, what percent of the data values are included in the box portion? What percent are included in each of the whiskers? on the ends of the box plots. Well, here, ladies and gentlemen, what we did here, we broke up the data into several groups here. But what they want to know here is that what percentage of the data is represented right here in just the box portion of it? Well, 50% of the data is. 50%. Because when it comes to box and whisker plots, ladies and gentlemen, in each quarter, so to say, it's broken up into fourths. You have 25% of the data there, 25% of the data there, 25% of the data there, and 25% of the data there. So if they're asking you how much data is just in the box part or just the box portion, 50% of the data. And on each of the whiskers on this other side, on each side, on either side, myself, we have 25% on each side. Okay. And when you add them all up, it's a total of 100%, which is what we have right there. All right, so now I'd like for you guys to go ahead and try your turn number 2, please. I left the example there, so a good way of starting off, ladies and gentlemen, is to what I did earlier. Here, put the least value, then go ahead and put your lower quartile, your median, your upper quartile, and then your greatest value. This, in my opinion, makes it a little easier to set up the data. Once you set that up, then you can go ahead and create your box and whisker plot or your box plot. All right, ladies and gentlemen, so what I did here, I went ahead and did start off by ordering data in order from least to greatest. Once I did that, I scratched them off and I started off by finding the median. The median, ladies and gentlemen, is 83.5 because you have 83 plus 84 divided by 2, which is right here. That's how I came up with 83.5 or 83 and 5/10. Then once I did that, that separated my data into two kind of sets here. Over here's one set and here's another set, and I found the medians of each of those sets, which the lower quartile was 78.5 and the upper quartile was 88.5, which is right there. And the smallest or the least value that we had here was 75. The largest value that we had was 94. So once we do that, ladies and gents, we have everything that we need to create our box and whisker plot or our box plot. Okay, so I'm not too fond of this example here on Go Math, but what can we do, right? The reason I'm not too fond of it is just, it's a good example, don't get me wrong. It's just the number line, the units they're using. Maybe in this case, I should have just given you guys an increment of 1. But anyways, here, if from here to here is 74, halfways would be 72. 76 and 80. This will make it a little more easier for us to read. 2. Alrighty. So, and if from here to here is 72, that means that halfway there would be 71, okay? So just keep that in mind. All right, so we know that our least value is 75. So that's where the whisker's going to start. 75, which would be right there. All right, let me use a small one here. Okay, 75, which is right there. All right, now it's going to go to, remember, our lower quartile, or Q1. That's where our box starts. And it ends at the upper quartile or quartile 3. So I need to start the box at 78.5, which would be right there. Remember, guys, right there, 79. So in between that would be 78.5. So, and it's going to extend all the way up to 88.5, which would be 89. So it'd be in between that. Here we go. That's our box, and I'm going to connect it there. Alrighty. And we know that our median is 83.5, so here would be 83, so 83.5 would be not quite at 4, but in between there. That's where it would be. And then the largest value that we had was 94, so that's where the whisker is going to extend to. And I connect it. There we go. And that's how your box and whisker plot should look like. I know I'm not the best artist, but hopefully I was good enough for y'all. And this is how the book did it. Oh. Okay, that's what the book says. All right, so now finding the interquartile range. A measure of spread is a single number that describes the spread of a data set. One measure of spread is the interquartile range, which can also be referred to as an IQR. The interquartile range, or IQR, is a difference of the upper quartile and the lower quartile. Remember, kiddos, here this is your least value, that's your greatest value. Here's your minimum, lower quartile, upper quartile, and that's your median. All right, so a lot of times we can also refer to these as Q1 and Q3. It's basically your interquartile range, ladies and gentlemen. It's the difference in the boxes, from your boxes, so to say. So here on A, they're telling us the upper quartile, or Q3, which is, because here's group A. If you see where the box goes, it's at 24, which is what they have right there, minus 20, which gives us 4. So the IQR, or the interquartile range, for group A is 4. All right, and for B would be 4.5. All right, so letter B, compare the interquartile ranges. How do the interquartile ranges describe the distribution of ages in each group? The interquartile range of group B is slightly greater than the interquartile range of group A. The ages in the middle half of group B are slightly more spread out than in group A. All right, it's just making comparisons, ladies and gentlemen. I'd like for you all to please go and solve number 3, please. All right, so please start off by putting group A's interquartile range. Alrighty, and please go and put group B's. All right, ladies and gents, and this is what you should have had. Okay, the group A's interquartile range was 700. Group B's was 450. So, but not only did they ask you to find them, they're also asking you to compare them. The interquartile range of group A is greater than group B's. And that's what the book has right there. Now, I'm sorry, I'm kind of rushing because I have 15 minutes. We're up to 12. All right, so finding the range. Another measure describes the spread of a set of data is the range. The range is a difference of the greatest value and the least value in a data set. Example number 3. The data sets show the ages of players on 2 professional baseball teams. Find the range of each set of data. So once again, ladies and gents, I always start off by arranging them in order from least to greatest. Then once you do that, you find the oldest age here in group A, or in team A is 39. The youngest one is 21, which is right there. So 39 minus 21, the range of team A is 18. Group B is 31 minus 21, which gives you 10. That is the range. All right. I'd like for you to go ahead and solve number 4, please. Start off with Miami's, please, and answer Miami's range now. All right, next, ladies and gentlemen, please go ahead and find Chicago's range. Alrighty. This is what y'all should have had. Those are the ranges. Alrighty, so now on your own, ladies and gents, I'd like for y'all to go ahead and do the guided practice, and the independent practice, okay? I want you to go up to questions, let me see, number 15, please. Question number 15. And please keep in mind some of the suggestions that I made. Y'all can go back to the video and see if you guys need some more help, okay? Good luck, ladies and gentlemen.